So question number 16. Page number 46. Gate to 191 1999. So in the computing Wilson's economic lot size for an item, by mistake the demand rate estimate was 40% higher than the true demand rate. So D1 D2 equal to 1.4 D1 he has given. So due to the error in the lot size computation, the total cost of setup plus inventory holding cost per unit time would rise above the true optimum by approximately. The total due to the error in the lot size consumption, the total cost setup plus inventory holding per unit time. So he is asking total variable cost equal to how much it will change equal to 2 D2 C3 same C1. So it is nothing but 2 into 2 is inside 2 1.4 D1 C3 by C1. So this also can be total variable cost equal to square root of 1.4 into 2 D1 C3 by C1 is nothing but square root of 1.4 into total variable cost of 1 initial value. So what is square root of 1.4? So what he is asking, what would be the rise in the true optimum? What would rise above the true optimum by x mass? So what is the rise increase in the because of the difference? So this value is equal to total variable cost is equal to 1.183 of the total variable cost of 1. So percentage increase from 1 to 2 is equal to 1.183 TVC1 minus TVC1 divided by TVC1. Separate TVC and 1.183 minus 1 by 1 into 100 equal to 18.3% increase. Answer is A is 1.4%, B is 6.3%, C is 18.3, D is 8.7. So answer is C. So most of the times answers are coming as C. Maybe some reason is there. So question number 15, page number 45, ME 2002. An item can be purchased for 100 rupees. So price of an item. Ordering cost is inventory carrying cost is 10% of the item cost. So 10 by 100, 10% of item cost. So C1 equal to 0.1 into P. It's nothing but 0.1 into 100, 10. If the annual demand D is equal to 4000 units, what is economic order quantity? 2D by C1. 2D is 4000, C3 is 200 by C1 is 10. Simplifying 400. Answers given is 50, B 100, C 200, D 400. D. So like this inventory questions mostly they give only in Wilson's model only. They won't generally ask beyond that. They didn't ask also ever. Next question. Consider the following data. Question number 11. Page number 45. Gate 2006. This one is important model. Consider the following data as given in table. Order quantity 500 greater than or equal to 500. Unit price. So discount model 10 and 9. Data is given as annual demand D equal to 2500 units per year. Ordering cost C3 is equal to 100 rupees per order. Inventory holding cost holding rate he has given 25% of unit price. So nothing else. So inventory holding cost is 25% of unit price. What is unit price? Whatever the value you take for calculation of economic order quantity. Suppose if you take 10, then it is 10. So economic order quantity EOQ equal to 2DC3 by C1. That is nothing but 2 into 2500 into C3 is 100 divided by 0.25 into, suppose for example for 10 if you take. So economic order quantity for 10 is you will get 447.21. So that means your economic order quantity is less than the actual value, right? So case 2. So it satisfies the condition. So you can cross check that. So as per EOQ, so if he has given that in the diagram, mentioned that for 10 unit 10 rupees economic order quantity is less than 500. We got the less than 500. So EOQ is equal to optimum order quantity equal to 447.21 units. So if you want to cross check this, you can do EOQ at 9 rupees is equal to 2 into 2500 into 100 divided by 0.25 into 9. So then you will get 471.4. So which is contradicting the order quantity condition. It is less than 500 but the given in the 500, so it is not the economic order quantity. Another method is cross checking, is you can calculate variable cost, whichever is minimum, that is obviously it is minimum will come for economic order quantity. So answers is A is 447, B is 471, C is 500, D is greater than or equal to 600. Answer is A. So next question is question number 4. Page number 43. Gate 2008. A set of 5 jobs is to be processed on a single machine. The processing time is given below. The holding cost for each job is K per day. So holding cost per job is K per day. So table he has given us job P Q R S T. Processing time. Processing time is P 5 days, Q 2, R 3, S 2, T 1. So a schedule that minimizes the total inventory cost. Which of the following schedule minimizes total inventory cost? Option A, T S Q R P. B, P R S Q T. C, T R SQPD PQRST. So actually the here there is nothing to do problem here. If you know the about inventory carrying cost, if you have idea of just processing time. So processing time nothing but amount of time to complete the job operation. So if you want to reduce the cost, that means the holding cost, so you need to process the least processing time job. So first, suppose for example, if I process T first, so it will be gone out. So the inventory for that is comes down. The total overall cost of the inventory will become, initially it is 5k. So once it goes out, it will become 4k. After 3 minutes another job, two processing time 2 minutes is Q and S. So it will go out for them, it is 2k 2k. So like that it will reduce. So to reduce the inventory carrying cost, you need to use select the job sequence based on shortest processing time. So based on shortest processing time, which is answer, T has to come first. So A or C. Next Q, either Q or S, anything. So S is there, A. Answer is A. If you follow any other method like first come first serve, so if your first job has to will go out after 5 minutes, till then remaining jobs has to be in inventory. So that means you need to pay more inventory cost. Suppose for example I am using first come first serve approach. So PQRST, for example, if you take the option D, so first come first serve, 5 after 5 minutes 5 days, sorry, after 5 days I need to pay inventory of for all the 4k for 5 days. 4k into 5, 20 rupees. Okay, holding cost is k per day, right? For job, holding cost per job is k per day. So for 5 days, after 5 days you need to pay 5 5 25 for, or 5 4 is 20 for, based on the method of first come first serve. If you follow the method of shortest processing time, so after 5 days you need to pay less, because by the time of 5 days, two jobs, three jobs will be gone out. So if you fastest processing time means T will be gone out on first day itself. After first day, S or Q will be go out after third day. Again S or Q will be go out another after fifth day. So that's why this problem is related to scheduling concept and as well as sequencing concept, as well as the inventory. So there is no need to use pen here. If you know the concept, you can get the answer in 5 seconds, less than 5 seconds, 2 marks. So that's what. If you know the concept, then only you can do. Otherwise, you don't. At least you know the what is shortest processing time methods, how to select the sequence based on shortest processing time. So what will happen, and we should know about inventory also carrying cost. Inventory carrying cost means, so the amount of cost has to pay for carrying the inventory. So if you know those two things, you can solve this problem. So next question number 2, page number 43, gate 2010. So it is some good question. Annual demand for the window frames. Annual demand D equal to 10,000. Each frame cost 200. Price of frame equals to 200. Price of item is nothing but P is equal to 200. So ordering cost per order equal to 300, that also rupees. Inventory holding cost is nothing but C1 is equal to 40%, 40 rupees per frame per year. The supplier is willing to offer 2% discount if the order quantity is 1000 or more. 2% discount if Q is greater than 1000. Supplier is often 4% discount if Q is ordering quantity is 2000 or more. If the total cost is to be minimized, the retailer should, if the total cost is to be minimized, the objective is minimization of cost. Minimize, the retailer should option A, order 200 frames, 200 frames per order. B, accept 2% discount. C, accept 4% discount. D is order economic order quantity. Solve this problem. First you need to calculate economic order quantity. Economic order quantity, EOQ, equal to 2 into D into C3 by C1, which is equal to 2 into D is 10,000, to C3 is 300, C1 is 40. Simplify that. After getting the economic order quantity, you will get approximately 400. So you need to calculate the total annual cost at economic order quantity is equal to nothing but D into P plus 2D C3 C1. So D is nothing but 10 power 4 into P is price of the item 200 plus 2 into 10 power 4 into C3 is 300 into 4. This is 1. So calculate total annual cost with R% discount. So R% discount, you need to take minimum 1000. Take Q 1000 equal to 10 power 4 into 200, 1 minus 2 by 100 plus what is an cost for D by Q is 2000. So I will write the formula first. So D by Q, which is of Q equal to 1000 into it gives a number of orders. You need to multiply number ordering cost plus Q by 2 into C1 into 1 minus R1 by 100. Sorry. So TAC with 2% discount is equal to 10 power 4 200 to 1 minus 2 by 100 plus D by D is nothing but 10 power 4 divided by 1000 into C3 is 300 plus Q is 1000 divided by 2 into C1 is 40 into 1 minus 2 by 100. Simplify, this is equation 2. Another one is 2AC at 4%, 10 power 4 into 200, 1 minus 2 by 100 plus Q2, 10 power 4 divided by 2000. This is for 4%, you need to, sorry, here it is 4 into 300 plus 2000 divided by 2 into 40, 1 minus 4 by 100. So out of these three, from 1, 2 and 3, whichever is minimum, then the quantity corresponding to the Q quantity corresponding to that value is ordering quantity. So answer for this problem is B. If you simplify and solve that, so it answer you will whatever minimum C, sorry, it is C. Answer equal to answer is C. So I will just repeat once again. First you need to calculate this methodology they have asked in GATE 3 times. So sometimes you need to calculate just only economic order quantity. At the time he won't give discount. Instead of discount he will give different prices. Price break, that is problem is called, which we have solved already earlier problem. That was also one of the GATE question. So if he gives price breaks, for each price break, suppose he will mention that if you purchase 500 quantity per order, so 500 quantity per order quantity, then you have to pay 10 rupees per item. If you purchase 1000 per order, then you have to pay 9 rupees per item. Purchase 2000 per order, then you have to pay 8 rupees per item. So as the number of order goes on increases, the price of the item decreases. But you have to order a quantity where the minimum price, optimum order means where generally optimum means minimum cost. The so we have to order a quantity at which the cost is minimum. That is called optimum order quantity. So for that you need to calculate economic order quantity. That order quantity is lying whichever is in the region range, then that quantity you can take. So that is one model. So in this model, instead of giving prices, he has given discounts on the price. So this is called discounted model. So in discounted model, what you need to do is first you need to calculate economic order quantity. So for that, after getting economic order quantity, you need to calculate total annual cost corresponding to at economic order quantity. So that cost, and then he has given two discounts. One is if it is more than quantity is more than 1000, more than equal to 1000, then 2% discount. If the quantity is more than equal to 2000, then it is 4% discount. So for each two discount rates, we need to calculate total annual cost. The total annual cost is nothing but fixed cost plus variable cost. Fixed cost is annual purchasing of an item, demand into price of an item, plus variable cost is nothing but combination of ordering cost and carrying cost, inventory carrying or holding cost. So we have to calculate for those two discount levels. We have two different quantities q's, q equal to 1000, q equal to 2000. For each for those two different discount levels, different ordering quantities, we need to calculate the total annual cost. So we have finally will get three equations. One is economic total annual cost at economic order quantity. Another one is total annual cost at 2% discount. Another one is total annual cost at 4% discount. So whichever is minimum, this the quantity Q corresponding to that minimum cost is the ordering quantity which we prefer.